Now when we look at the first problem here, we notice that we have our blob is x plus 1. We have an x plus 1 to the 2 and x plus 1 to the 1. So I'm going to make a substitution. I'm going to let, and this time I'll use b for blob, be equal to parentheses x plus 1. So what I'm going to end up with is, this is going to be a u and a squared and just a u to the 1. So this is 4u squared minus 12u. Factor out a greatest common factor of 4u, and you're going to be left with u minus 3. Now, what I need to do now is just to resubstitute. So what do I know? I know u is x plus 1. So wherever I have a u, I'll replace it by the parentheses x plus 1. So I'll get 4 times x plus 1 times x plus 1 minus 3, or 4 times x plus 1 times, remove parentheses, x plus 1 minus 3 is going to be equal to x minus 2. Now, if I look at this problem, this is something that you probably have forgotten about, or if you haven't, it's something you probably wanted to forget about. And that's the idea that you have the difference of cubes, where if you remember, a cubed minus b cubed is a minus b times a squared plus ab plus b squared. I notice that I do happen to have a blob, which is this guy right here. So I'm going to let b be equal to parentheses 4x plus 1. So this then becomes a b cubed and then minus 8. Now if I look at the formula, I need an a and a b. So that says that in this instance, a is going to be just b, because the cube root of b cubed is b. And b in my formula is 2, because the cube root of 8 is 2. So what am I going to have? I'm going to have a minus b, or b minus 2 times a squared. So b squared plus a times b, 2b, plus b squared, 2 squared. So this then becomes b minus 2 times b squared plus 2b plus 4. Now I need to go back and substitute back in for b. b is 4x plus 1. So wherever there's a b, I'll put a 4x plus 1. So this would be 4x plus 1 squared. This would be 2 times 4x plus 1. So that's b squared. That's b. So this becomes b minus 2 times b squared plus 2b plus 4. Now removing parentheses, here I get 4b plus 1 minus 2, so, or 4x, so it's 4x minus 1. And I'm just going to leave well enough alone and quit them while I'm ahead. This is 4x plus 1 squared plus 2 times 4x plus 1 plus 4. I could multiply everything out if I like, but I'll be honest with you, I'm just too lazy, and no, I don't like. Now, Is there a blob? Well, there is, and this is going to be an x to the 1/2. And what we normally like to do is, what happens with this is that when we're looking at particular problems, we're saying to ourselves, you know, that 8 is out of place. But when we're in calculus, you're going to see some of the problems are going to be on the next page. Actually comes out of doing a calculus process where you have to rearrange things in order to make them work. So normally we like to see it this way: 6x to the 1/2 times 2x plus 3 plus 8x to the 3/2. Now it says x is greater than or equal to 0. If you remember, x to the 1/2 is the square root of x. And if I look at the idea of the square root of x, then I know that the radicand, which is x, must be greater than or equal to 0. So that's where they come up with this, because I'm dealing with the square root. Restricts the domain. So in this instance, I'm going to take out a 2, because 6 and 8 have a factor of 2. And then the smallest power on x is x to the 1/2. Now what's that going to leave me? Well, from the 6 I'm removing a 2. That gives me a 3. I'm taking the x to the 1/2, so he's gone. Then I've got this set of parentheses, 2x plus 3, plus, from the 8 I'm taking a 2. That gives me a 4. Then from an x to the 3/2, I am going to remove 1/2. So this gives me 2x to the 1/2 times, I'm going to go ahead and remove parentheses here. This is 6x plus 9 plus 4. 3/2 minus 1/2 is 2/2, or 1. So this is 2x to the 1/2. Combining like terms, 6x plus 4x is 10x. And then just a 9, so plus 9. Can't do anything more with it, so then this becomes your final answer. With this particular problem, again, I've got the same issue. Greatest common factor in this case is going to be a 4. Smallest power on the x is x to the negative 2/3. Now the reason why x can't be 0 is if I look at x to the negative 2/3, this is 1 over x to the 2/3, and you notice the denominator can't be 0. So that means in this case x can't be 0. So it happens to be a domain restriction. Don't want you to necessarily worry about it. And then what am I going to be left with? Well, I'm taking a 4 from the 8. That gives me a 2. From the x to the 1/3, I'm going to remove a negative 2/3 minus, I'm taking a 4. And from an x to the negative 2/3, I am removing a negative 2/3. In other words, I'm taking the whole thing completely. So this is going to form a plus. This is going to form a plus. So this says I've got 4x to the negative 2/3 times 2. Now x to the 1/3 plus 2/3 is 3/3. That's just an x. Minus x to the negative 2/3 plus 2/3 is x to the 0 power. Or 4x to the negative 2/3 times 2x minus 1. And then that happens to be what your final answer is. Now you don't have to put all the steps that I put in, but I do them so that you can have something to reference this